Hello everyone, welcome back. Today we will discuss about the IUPAC nomenclature of epoxide. Epoxides are heterocyclic compounds. Now what are heterocyclic compounds? Heterocyclic compounds are cyclic compounds having two or more different kinds of atoms in the ring. For example, carbon, hydrogen, sulfur, oxygen, etc. Earlier, we have discussed about cycloalkane, benzene, naphthalene, anthracene, phenanthrene. They are all called homocyclic compounds because they are made up of, they are actually having rings made up of atoms of the same type like carbon. Here is the structure for and some examples of homocyclic compounds. You see benzene, cyclopentane, naphthalene, anthracene, phenanthrene. They are ringed compound or cyclic compound, and the ring is made up of same type of atom, which is carbon. Here are some examples of heterocyclic compounds. See, these are also cyclic compounds, but one or two members of the ring are made up of atoms which are different from that of carbon. So that's why they are known as heterocyclic compounds. Hetero means different and cyclic means they have a ring structure, and so they are called heterocyclic compounds. Today we will focus on how to write the IUPAC nomenclature of epoxide rings. Now, what are epoxides? Epoxides are compounds. Epoxides are three-membered heterocyclic ring compound containing oxygen atom as one of the members of the ring. So, epoxide have three-membered ring compound. You know propane. Propane is a three-membered carbon open chain compound. When you tie both the ends of the propane, you get cyclopropane, which is a homocyclic compound because the ring is made up of three carbon atoms, same type of atoms, and so homocyclic compound. Now, when you replace one of the carbon with oxygen atom, it is known as epoxide, and it is a heterocyclic compound because the ring is made up of two carbon atoms and one oxygen atom. Now, epoxide rings are also called epoxy or Oxirane. They are called cyclic ether. You know the formula, general formula for ether is ROR. So, epoxide is a cyclic ether, ROR, but the ether is cyclic, and the ether is present in the three-membered cyclic system. So, it is called a cyclic ether. You know from the priority table that the ether functional group always comes as a prefix in front of the parent name. And to find out the IUPAC name, the first step, which you all know, is to find out the longest chain. After finding out the longest chain, we need to do the numbering. These rules are almost same in all systems. So, Now you need to do the numbering, and so the numbering is done in such a way that the substituent gets minimum number, which is not unknown to you. This rule is not unknown to you. If the other substituents are present, they also come at the prefix. That also you know. Substituents' names always come as a prefix. So ether group behaves as a substituent and its name comes at the prefix. Along with the epoxy group, if there are some other substituent, their name also comes as a prefix. While writing the names, now you have to follow an alphabetical order. There are two ways of naming epoxide. One is epoxy method and other one is Oxirane method. But when you have a longer chain, then epoxy method is the preferred one. You will understand this better when we will do examples. Now let's see some examples. Look at this compound. Okay, so what does the rule say? The rule says that you have to choose the longest chain. So which is the longest chain? The longest chain is this. Now the next step is we need to do the numbering. The numbering should be done in such a manner that the substituent gets minimum number. So which is the best possible way to number? The best possible way to number is in this manner. So you see that the epoxy ring is between these two carbon atoms, 1 and 2. So the parent name is butane because it has 4 carbons. It is a 4-carbon chain, and so the parent name is butane. The substituent is epoxy because it is an ether, and ether always behaves as a substituent and come as a prefix name. So where is this epoxy group situated? This epoxy group is situated at 1 and 2 position. So guess what will be the name of this compound? The name of the compound is 1,2-epoxy butane. 1,2-epoxy butane. And if you follow Oxirane way of naming, then it is called ethyl oxirane. Here there is a ethyl group. This is an oxirane. Epoxides are also called oxirane. So ethyl group is present at what position of the oxirane? 2 position. So the name is ethyl 2-ethyl oxirane, or you can name it as 1,2-epoxy butane. Let's look at the next example. Again, the first step is to choose the longest chain. So which will be the longest chain? 1, 2, 3. So the numbering goes like this: 1, 2, 3. So the parent name is, if it is a 3-carbon compound, the parent name is propane. There are 2 substituents. Say, what are they? They are epoxy and methyl. Both comes as a prefix name. So epoxy group is present at 1 and 2 carbon. So it will be 1,2-epoxy. there is a methyl group at 2 position. There is a methyl group at 2 position. And so, what is the IUPAC name of this compound? The IUPAC name of this compound is 1,2-epoxy 2-methyl propane. See, both the substituent name came at the prefix, but why epoxy is named before methyl? Because E comes before M in alphabetical order, and so we have to name epoxy first and then methyl in the prefix name. So the name is 1,2-epoxy 2-methyl propane, or if you want to name it in by Oxirane method, then Oxirane is this. Epoxide rings are called Oxirane, and Oxirane has 2 methyl groups at 2 position. So what is the name of this compound? It is 2,2-dimethyl oxirane. If you name it by Oxirane method, it is 2,2-dimethyl oxirane. Otherwise, it is 1,2-epoxy 2-methyl propane. Let's look at the next example. The parent ring is this is the way you number it. The parent name is cyclohexane, and the substituent here is epoxy. So what is but the epoxy group is present at 1 and 2 position. So it is 1,2-epoxy, and the parent name is cyclohexane. So what is the IUPAC name? The IUPAC name is 1,2-epoxy cyclohexane. Look at this compound. First, we have to choose the longest chain. The longest chain is this 1, 2, 3, 4, 5. So the numbering goes like this: 1, 2, 3, 4, 5. So if it is a 5 carbon chain, then obviously the parent name is pentane. The substituents are epoxy and methyl, which comes as a prefix name. Epoxy is present at 2 and 3 position. Methyl group is present at 2 position. Between epoxy and methyl, who will get preference? Epoxy will get preference because E comes first in the alphabetical order before M. And so, I think you can write the IUPAC name on your own. So, the IUPAC name of this compound is 2,3-epoxy 2-methyl pentane. And if you want to write by Oxirane method, then the name of this compound is, this is a Oxirane ring. So you have 2 methyl groups at 2 position and an ethyl group at 3 position. So how are you going to name this compound? Ethyl should be named first, then methyl. So 3-ethyl 2,2-dimethyl oxirane. So I am showing you both ways of naming. But when we go to longer chain, epoxy method is more preferred than Oxirane method. Look at this compound. This is an epoxide having a long chain. Okay, so let's find out the longest chain first. The longest chain is 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the longest chain contains 11 carbons. The numbering goes like this. The parent name is undecane because it has 11 carbon. So it is undecane. Now how many substituents you have? You have 3 different types of substituents: chloro, epoxy and methyl. See, chloro, epoxy and a methyl group. So, but all these substituents, all these names comes in at the prefix before the parent name. So, the substituents are this: chloro, epoxy, methyl, and they come as a prefix name. Now, among this chloro, epoxy and methyl, what will be the order of writing? C comes before E and E comes before M. So, chloro will get preference, then epoxy, then methyl. So, now just write the positions of the substituents. So, the chloro group is situated at 1 position, epoxy is between 2 and 3 carbon, methyl is present at 9 carbon. So, what is the IUPAC name of this compound? The IUPAC name is 1-chloro, 2,3-epoxy, 9-methyl undecane. 1-chloro, 2,3-epoxy, 9-methyl undecane. Now look at this next example. What is the difference between this example and this example? We have just replaced this chloro group with the amino group. Now, if you remember, amines are principal functional group and its name comes at the suffix. So, again, let's count the longest chain. Let's find out the longest chain. The longest chain is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So, the longest chain is again undecane. So, the parent name is, the numbering goes like this. The parent name is undecane. The substituents here are methyl. Okay, the principal functional group here is amine. Substituents are epoxy and methyl. So, this substituent names will come as a prefix, and so the name of this compound is 2,3-epoxy because the epoxy group is present at 2 and 3 position. Methyl group is present at 9 position, but epoxy came before methyl because E stands first in the alphabetical order than methyl. So, 2,3-epoxy undecane, 1 amine. See, now the amine name came as a suffix name because it is a principal functional group. Its name comes at the suffix. Now look at the last example. What are the things you are having? What are the groups you are having? You are having a epoxy ring, you have a carboxylic group, you have a NH2 group, and also you have a methyl substituent. You know that epoxy and methyl, they both behaves as a substituent, and their name comes in the prefix before the parent name. But there are two principal functional groups now, amine and carboxylic acid. Now when you have two principal functional group, one should get preference over the other. So who will get preference over the other? Carboxylic acid. If you remember the priority table, always you have to remember the priority table. So if you remember the priority table, carboxylic acid group comes first in the priority table. So it will get preference, and its name, carboxylic acid group name, will come as a suffix name after the parent compound name. And the amino group, though it is a principal functional group, its name will come at the prefix. So here also find out the longest chain. Now you have to start numbering from here, not from here, because you are finding out the longest carbon chain. So your numbering should start from this carbon. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the numbering goes like this. What is the parent name? The parent name is dodecane. Because it has 12 carbon, it's a 12 carbon chain, so it is dodecane. The substituents, the principal functional groups are amine and carboxylic acid. But who gets preference? Carboxylic acid is a more priority group, and so it comes as a suffix name after the parent name, and amino group becomes the prefix name in addition to other prefix name like epoxy and methyl. Now, what are the names that are coming in the prefix? Amine, epoxy and methyl. So A comes first. So amine group will be written first, then epoxy, then methyl. So what is the IUPAC name of this compound? Where is the amine group situated? Amino group is situated at 2 position. So an epoxy ring is between 3 and 4 carbon. So 3, 4 epoxy. Methyl group is at 10 position. So the IUPAC name of this compound is 2 amino, 3, 4 epoxy, 10 methyl, dodecanoic acid. 2, 10 methyl dodecanoic acid. Since there is a carboxylic acid group present, and the suffix name for carboxylic acid is oic acid, and so it came as a suffix after the parent name, and so the parent name is now dodecanoic acid. So the name of this compound is 2-methyl, 3,4 epoxy, 10-methyl dodecanoic acid. That's all for today. Before I end, I should say that you should remember this priority table. Go through this priority table again and again and remember it carefully so that you can do the IUPAC nomenclature properly. These are the these are the priority table, 2 priority tables, one for the substituent and the other one is for the principal functional group. You have to learn it by heart, the order, the names, everything, suffix name, prefix name, everything you have to remember it by heart to write the IUPAC nomenclature correctly. So here I end. If you like my video, please subscribe, like, share and comment. Before I end, I want to end with a thought by Rabindranath Tagore. You cannot cross the sea merely by standing and staring at the water. So, what does it mean? To do something, you have to put lot of effort. Just by staring or just by becoming ambitious and not doing anything will not help. You have to put effort, hard work, consistent hard work, then only you can achieve your goal. Just dreaming will not help. Thank you and bye bye.